Let me take you back 300 years. Before rockets, before airplanes, before satellites, there was just a question: why do things move the way they do? A man named Isaac Newton answered that question with just 3 simple rules. And today, those same rules are what launch rockets to Mars, guide hypersonic missiles, and keep satellites orbiting Earth. So this is not just physics. This is the story of how 3 simple ideas shaped the most advanced technology on our planet. Every engineering problem, whether it's a rocket, a submarine, or a missile, boils down to one question: right finger. How does force change motion? Think about it. A rocket leaving Earth, a missile changing direction mid-air, a submarine moving silently underwater. Completely different environments, but the same physics. Newton didn't just discover laws. He gave engineers a universal language to control motion. Let's start with something simple. Imagine you're sitting in a car. Suddenly, it brakes, and your body jerks forward. Why? Because your body didn't want to stop. That is inertia, the tendency to resist change. In fact, everything in the universe is lazy. A satellite keeps moving for years. A bullet keeps flying forward. A submarine keeps gliding. Objects don't change motion on their own. They need a force. This idea is so simple, yet it explains motion across the universe. Now we move from idea to power. Newton's second law gives us a formula. Right finger F equals ma. This is the equation engineers live by. It tells us more force, right pointing arrow. More acceleration. More mass, right pointing arrow. Harder to move. So every engineer is solving one problem. How do I maximize force and minimize mass? Because that's how you win in rockets, missiles, and machines. Let's make this real. Push a bicycle, easy. Push a truck, almost impossible. Same force, different mass. Now scale that to rockets. A rocket is incredibly heavy, so engineers increase thrust, reduce weight, even drop parts mid-flight, staging, and in missiles, low mass plus high force equals extreme acceleration. Physics isn't just theory, it's design strategy. Now comes the law that actually makes things move. Right finger. Every action has an equal and opposite reaction. When you jump, you push the ground down. The ground pushes you up. When a rocket fires, it throws gas downward. The gas pushes the rocket upward. No air needed, no magic. Just pure physics. This is why rockets work even in the vacuum of space. Now let's combine everything. A rocket launch is not one law. It's all 3 working together. First law, the rocket resists motion. Second law, engineers calculate how much force is needed. Third law, engines create that force. Remove any one of these, and the rocket never leaves the ground. This is where physics becomes choreography. Now let's push physics to the extreme. Imagine traveling at Mach 10, over 12,000 kilometers per hour. At this speed, air behaves almost like a solid. The surface becomes plasma hot. Small movements create massive forces. This is not normal engineering. This is Newton's laws operating under extreme conditions, and nations are racing to master it. At Mach 10, physics becomes unforgiving. First law, the missile wants to keep going straight. Second law, even tiny turns need massive force. Third law, small control surfaces create huge reactions, so engineers are constantly balancing control versus destruction. At this level, even physics becomes dangerous. Now let's flip the problem completely, from extreme speed to extreme distance. A Mars mission travels over 225 million kilometers. But here's the surprising part. The engines are not always running. Instead, one push, then coast for months. This is inertia, working in our favor. Let's break it down. First law, spacecraft keeps moving without fuel. Second law, more fuel means more mass, a huge problem. Third law, rockets push themselves in vacuum. And then comes the hardest part, landing. From 20,000 kilometers per hour to 0. No runway, thin atmosphere, only physics, perfectly calculated. Now zoom out. These laws are not just academic. They power trillion-dollar industries, space exploration, defense systems, global shipping, satellites, and communication. Every time you reduce weight, every time you increase efficiency, you are applying Newton's laws. Interestingly, you experience Newton's laws every day. GPS and satellite navigation rely on the first and second laws. Safer cars, with seatbelts and airbags, are engineered around inertia. Space exploration is fundamentally Newtonian. Even global trade, from hull design to routing, is optimized by the second and third laws. Newton didn't just change science, he changed your daily life. Let's end with something powerful. 3 laws. That's all it took. Resist change. Objects stubbornly maintain their state of motion, whether still or moving, unless a force intervenes. Inertia is the default setting of the universe. Force controls change. When force does act, F equals m asterisk a tells you exactly how fast change happens. Mass resists, force enables, acceleration is the result. This equation is the engineer's most powerful tool. Every push creates a pushback. What it means is that no force acts alone. Every action generates an equal and opposite reaction. This is the mechanism behind every rocket, every propeller, every jump, from a falling apple to Mars missions. It's the same universe and the same rules. That's the beauty of physics, simple but limitless. Newton is one of the most famous names in history, but he's just one of hundreds of incredible minds who shaped the world we live in today. Behind every rocket, every aircraft, every breakthrough, there's a story, a person, a journey. Now I want to hear from you, Downfinger. Who is a hero you think deserves to be featured next? Drop their name in the comments. I might turn your suggestion into the next video. And if you enjoy stories like this, subscribe, because we're just getting started.